environmental studies and set up environmental laboratory to continue his research on containment fate and transport in the subsurface system. Earlier, Dr. Sharma served at the Department of Earth Science, Uppsala University, Sweden as an assistant professor. He was involved in research related to carbon dioxide and nanomaterial transport and retention. He also worked in different universities like University of Western Ontario, Canada, also Aalborg University, Denmark, as a full-time researcher and pursued his PhD dissertation at Washington State University, USA. Dr. Sharma acquired his basic degree from Stuttgart University, Germany, the Indian Institute of Technology, Kharagpur, and Rajendra Agricultural University, Pusa. In his career, he has procured several national and international research grants and collaborated his research with several leading institutes worldwide. He has published more than 75 peer-reviewed journals in major environmental journals and serves as an editor board of different reputed journals. So, with this short introduction, I welcome Dr. Prabhakar Sharma for your talk, and we are eagerly waiting to listen to you. Welcome.
Thank you, ma'am, for such a nice introduction. And once again, I thank JNU and this initiative for giving me this opportunity of presenting my work, some of my studies related to microplastic to you. I will be happy to answer the question as guided by the coordinator at the end of this talk. Please allow me to open the PPT. Is it visible now? Is it?
Yes, sir, it's visible.
Okay. Thank you again. So today's talk will be revolving around the impact of microplastic pollution in the ecosystem, and I'll give you an outline. But before that, just 2 days ago, I was at a very popular place, one of the Shiv Mandir Jyotirlingam in Jharkhand, near Devghar. It's today Shravan month is also starting, a very pious month. But some of the pictures are really disturbing there. I was invited there to work on, help them on the solid waste management. So we can see here how the plastic bottles and other materials are lying around there, and they are struggling very hard to find sustainable solutions for that. So I was more keen to work on their solid waste, so which includes a number of things, including like polythene bags, flour, and other offering materials for the temple. And a couple of years ago, the power grid was helping them in sorting and disposing this, but now it is not functional, so I'll see how I can help it. So we can see how the plastics are problematic and need to work on this.
Excuse me, sir. Hello. Sir, the slides are not changing.
Okay, let me change the approach here. Maybe I'll share the full screen so that that will be better.
Sir.
Okay, sorry about that. Full entire screen, yes. Can you see it now?
Yes, sir. It's visible.
Yes, is it moving
yes,
now?
It's moving now. Yes,
okay.
Sir.
Thank you very much. So I was talking about this image of Devghar, one of the temple here, and how the plastics are a problem there, as well as the solid waste required to be sorted, as well as need to be monitored. So this is the outline of today's presentation. I will start with an overview of plastic pollution so that we understand them well. And then I'll highlight some of the important characteristics of the microplastics especially. And then talk about the interaction of microplastic with ecosystems. And then, as I said in the beginning, and this is the goal of also the LIFE program, that how their microplastics are connected with the Sustainable Development Goals, and also try to suggest some of the possible solution for that. And then the next part of the talk would be focusing on some of the mechanism of the microplastic transport, especially in soil and groundwater, because this area I had been working a lot in not only with the microplastic but other micro and nano size particle as well. And those knowledge, those mechanisms are still can be used as well as useful for microplastic movement and their mobilization. And then I'll have a short case study, which is one of the recent paper by our group. And this study was basically conducted in the Bay of Bengal, in the Bangladesh part. And then just a few recommendations about the future research opportunity related to microplastics. So plastic production in the present. So an estimated plastic production has almost reached to 4 billion tons now, and this data is in 2020 around the globe how much plastic are being produced. So if we are producing something, that means they should end up especially ultimately to the environment. The presence of especially different form of plastics occur in multiple water bodies, including ocean, river, lakes, as well as the wetlands. And also not only the water bodies, they are present in the atmosphere as well as the terrestrial environment, and now they are even being formed in the groundwater. So there is a concern here. Normally the marine litters are human created, that means they especially posed by the anthropogenic activities, and not only that, they are mostly going from the land based pollution, most of the plastics. So plastic related research are epicenter in this these days. A lot of research group around the world are working on the plastic, and it's not only in the plastic and also with the smaller size plastic, how they are related. And multiple disciplines are working together, not only the environment, but also the health, the chemistry, as well as physics. So all aspects, the understanding of the different aspects are important in order to deal with the plastic pollution. So what are the basic nature of plastic? So plastic, as we know, they are very light. So they are normally thrown away, or they can wash easily, or they also float in the air because they are very light in terms of their thickness, or depending on the shape of the plastic, and they are ultimately reaching to the ocean via land as well as the river or other water bodies. So some of the properties of the plastic are that generally they are non-biodegradable, they are lighter so they can float, and they brings very high strength. That is why the production are increasing, because they have lot of application, lot of good properties in multiple sectors. So they basically can entangle as well as ingested by animals very easily, whether it is land-based or it is water-based animals. So some of the common sources are of plastics are that a wide variety of anthropogenic compound can become marine debris, such as plastic bags, balloon bottles, So if we just talk about the ocean, in that almost 80% of the plastics in the ocean are land-based sources. Of course, some of them are directly reaching to the ocean, but mostly in the land-based. Here are their sizes. Like we are talking about microplastics, so we have to understand based on their sizes. So lot of different sizes are available here, starting from the original product, which are mostly the macro sizes, like bottles, bags, and different materials. Then once they become smaller in sizes, they are called mesoplastic, which is something bigger than 5 millimeter and smaller than 25 millimeter in their sizes. But the smaller than that are called microplastic, which is less than 5 millimeter. And the other categories also sometimes some researchers define is called mini micro, which is less than 1 millimeter but greater than 1 micrometer. Then more recently, the plastics are also found and studied in nano sizes. That means if they are smaller than 1 micrometer sizes, then they are defined as the nanoplastic. There are some, of course, basic error in different definition, which was being used conventionally from long. When we define the microplastic by these two sizes, because it is defined as less than 5 millimeter sizes, but they are not basically micrometer sizes. But still, we are defining, and all of us are using this definition of microplastic. But of course, the nanoplastic are slightly smaller sizes, which are also being studied. Based on their types, if we see like how they are coming into that, then that can be categorized whether it is primary microplastic or secondary microplastic. So as by name it is defined, that means when the microplastic are directly being present or being injected in the atmosphere or environment in their microplastic sizes, then they are called microplastic. For example, fibers. Fibers are generally being found in the wastewater when we wash the clothes or the floor or other material. Then these are very common and easily being washed away with the sewage water. Or like microbeads, for example. Microbeads are having a lot of useful properties, like they are being used in cosmetics industry. So they are already in the microplastic sizes, but they can be found, or pellets, for example. But the film, fragments, foams, they are considered to be the secondary microplastic. That means when the plastic products are chemically or physically degraded, or they converted into the microplastic sizes, then we define them as a secondary microplastics. Now, if we see the different pathways of the microplastic, especially in the river, this review paper was published in Science of the Total Environment, and it was nicely combined different aspect of microplastic, especially in the river water system. And in this image, we can define them based on their sources and sink. For example, there are multiple sources of microplastic to come into the river water, like industrial effluents, agricultural activities, or like construction work, wastewater treatment plant, landfill site, or household activities, as well as this fishing net gears, because they also being used in the water bodies for fishing purposes, but they sometimes become old and broken down into the microplastic sizes and go to the river. So these are the common sources of microplastic in the river water. Then a lot of physical, biological and chemical activities happen further in the water bodies, and as a result during the travel they can also not only flow and reach to the ocean, but they may also settle back. That means they can sink or being utilized by different purpose. For example, the animals which are present in the water, if they are ingesting the water, together with that microplastic can be also taken by the fish, or they can settle or attached with the aquifers like sediments of the river at the bottom, as well as can infiltrate together with the water bodies and can even go further to the groundwater. This is how they are reaching to the groundwater as well as the sediments. Then they may also sometimes we use the water for drinking as well as the irrigation purpose. That means we are also taking together the microplastic if they are mixed with the water. So these are some of the common use, and otherwise they may ultimately stay with the water or can pollute and go to the ocean or sea. Now, how they are interacting with the ecosystem? I just included this 4 common pathways. That means if the microplastic goes to the soil, then they may also change the property of the soil as well. For example, changing the permeability or temperature of the soil if they are mixed with or present in the soil. And not only that, microplastic can also be a vector for the harmful pathogens. That means depending on the, of course, the microplastic sizes, because the smaller the sizes, bigger the surface area. So these pathogens can attach to their surface and move together with the water wherever they mobilize, wherever they transport. Not only that, microplastic can be magnet for other toxic compounds like heavy metals or other organic compound, which if they are present in the water, then they are more likely to get attached to the microplastic surfaces and can have even become more toxic for different purposes. Or ultimately, as I said before also, this microplastic, whether it is pure microplastic or together with the toxins or other pathogens, they may also get ingested by the aquatic animals. So lot of ways that they can be interacted. Now, in this cartoon, I just try to highlight the presence of microplastic in the different product. For example, they are going to the soil and groundwater. Nowadays, there are a lot of studies has shown that they are found in the food like salt, sugar, beer, coke, or many other products. These microplastics are being present, as well as they are found in the aquatic animals, including fish, mollusks, or many more. And they are also present in the further in the aquatic system, or they are even present in the atmospheric air, because recent studies have shown that microplastic are being transported long distance just by the atmosphere. So they don't even require to be in the water or in the soil, but they can get transported with the air and even pollute the remote location like mountain, or even the where we don't expect any pollutants, any contaminants like microplastic to be there, but because of the wind or atmospheric transport, they are being also present. Now, if we talk about the microplastic pollution, then some of the factors which need to be focused. For example, we have to understand the sources. Not only for the microplastic pollution, but for any pollution, we must understand the source. Because if we don't know the what are the sources of microplastic, then we cannot even do there any mapping, any quantification, or even further the remediation, if that is our goal. So sources are very important, because sources also tells us what type of microplastic are there, because microplastic are can also be of different type of polymers like PTFE, polystyrene, polyethylene, or many more. So chemically they can be different, they can be also different by the quantity, quality, or many more. So if we clearly identify the sources, then we can do some of our job in understanding the microplastic pollution. Then their interaction, that means how they are interacting with the surroundings or by themselves. There again we require the knowledge of type of polymers which are the parent material for the microplastic, or are there any other toxic material which are being used to manufacture some product of the plastic, because they may also be present together with the microplastic. Then their physical behavior as well, like flow condition, if we talk about like water, flowing with the water or flowing with the air. So overall how they're interacted. And then we must know about the sink, like how likely and where they are staying, and whether they are sticking or getting absorbed or getting reacted on in what concentration. So we need to understand the sink. Then only we can talk about the ecological disturbance. That means how microplastic can lead to the global ecological disturbances. So this is some of the points, in my opinion, are important if we try to understand the plastic pollution, microplastic pollution. So now I try to connect the microplastic pollution or plastic pollution with the sustainable development goal, because these are the set 17 goals and very important in order to understand their interaction with the environment. Because the microplastic management is very critical in achieving this goal. And this is because the microplastic has direct impact on the environment, economy, as well as to the society. I will try to go through some of the important ones in my opinion, and this was very well summarized in one of our review paper published 2 years ago in Sustainability Journal. If you want, you can read more, but I just try to summarize. So if I just see the goal 14, it talks about the marine resources, like how to conserve and sustainably use this ocean, seas, and marine resources. And plastic waste can basically harm the marine life and the ecosystem, as had been studies. And because the microplastic pollution poses a threat to the marine life, which can affect the sustainability of fisheries as well as the tourism, if it is related to the ocean. So the proper plastic management can reduce the amount of microplastic that generally end up in the ocean, and also mitigate their effects. And there is especially this one of the target within this sustainability sustainable development goal 14.1, which talks about the plastic, more specifically that by 2025 prevent and significantly reduce the marine pollution of all kinds, in particular from land-based activity, including the marine debris and nutrient pollution. So here they are mentioning about the marine debris, which is basically the plastics floating in the ocean. So this is supposed to be measured by the indicator 14.1.1, that is the index of coastal eutrophication and floating plastic debris density. So how dense and what are the density of the total waste in the microreserve. So this is being specially targeted. Some more here, Sustainable Development Goal 1, which talks about the ending the poverty in all forms, and natural ecosystems are more vulnerable to the plastic waste as they also negatively affect the ecosystem services and livelihood, especially in the coastal communities, if we talk about that. And it's more common in less developed or low income country because their managements are not up to mark and how to handle the plastic related pollution in the coastal area. Even in the Sustainable Development Goal 2, which says about the ending the hunger or talk about the food security. So microplastic in agriculture, soil or vegetable, fruits and seafood are a potential threat to the sustainable food production system as well as the food security. Microplastic in soil are not only the threat to the soil health, soil fertility and crop production, but also to the food security and human health. So plastic pollution is very important to and directly connected to this goal as well. Couple of more here. Goal 8, which talk about the decent work and economic growth. Proper plastic management can create employment opportunity in the recycling sector, especially those which are involved because of their volume, huge volume of plastic waste are being created. So if we recycle properly, then it can even help in the economy. Goal 11, which talk about the sustainable cities and communities. So managing plastic waste in urban areas can help in reduce pollution, enhance public health, as well as improve the overall city sustainability. Then goal 12, responsible consumption and production. So plastic waste generally have a negative impact on the environment, affecting both air and water quality. So reducing the plastic waste and managing it properly can lower the consumption and waste, promote the resource efficiency as well as support to the circular economy. In goal 13 are related to the climate action here, and plastic waste basically releases a huge amount of greenhouse gases if they are being burned or decomposed in landfills. So adequate plastic management can improve these emissions and contribute to climate change mitigation. The last one which I wanted to discuss here is the goal 15, which is life on land. So plastic pollution has devastating effects on the terrestrial ecosystem, including land animals as well as the plants that may ingest plastic debris or entangle it. So I think there are a lot of survey, lot of study about nowadays how the plastics or especially the microplastic are found in the different part of the animal, including the blood as well. And not only that, if we see the plants, nowadays number of study which talk about the plastic, the microplastic can be taken by the plant as well. So both has the applicability and connection with this goal. So in summary, achieving the sustainable development goal require effective plastic waste management policy as well as the practices and initiative that tackle the multifaceted challenges of the microplastic pollution. I just summarize here some of the points here of unsustainable trend on the plastic pollution. Many single-use plastic items are very difficult to recycle or can only be recycled few times before they become unsustainable as plastic waste. Some of the previous studies have estimated that half of the global mismanaged plastic waste is generated by countries like China, Indonesia, Philippines, Vietnam, Sri Lanka. But this was not true because it was this data was mostly based on the these countries mostly import the poor quality plastic waste from the high income countries for recycling purposes. So this data was overestimated, and in order to curb that, there is an amendment on the Basel Convention that which are designed to restrict this kind of international trade of plastic waste. So basically trying to encourage if plastic waste are being generated in India, for example, then one must manage within the country, within the territories. So that may help to overestimate the plastic pollution in some other countries. Changes in the industrial production also help, like end of use disposal, mitigation and impact of the plastic in the environment. So we can say that prevention, reuse, recycling, recovery and disposal can be applied in order to reduce the plastic pollution. Some more specific points related to microplastic pollution. It has largely been ignored long back by the scientists as well as the public and policymakers until more recently, because they are not directly visible. Because if they are in the range of microplastic, then we cannot see by naked eye mostly if they are alone. But of course, if they are in bulk, one can see it. So that is why it was not paid attention earlier. But now growing body of evidence of microplastic accumulation are present in the agriculture soil as well as fruits and vegetables, drinking water, and even the seafood. WHO has recognized these potential microplastic hazards in municipal and bottled drinking water as well, which largely depend on mostly on the water sources, that means from where this water has been used for application, as well as the design of the plant and method for analysis as well. Due to their ubiquitous and persistent nature and the small sizes, microplastic health effect and toxicities are the major threat to the sustainability. Some empirical data on microplastic ecological and in human health impact are still relatively lacking. But I have also thought about some possible sustainable solution of microplastics. So urgent need to move from reliance on unsustainable fossil fuel based plastic to more sustainable bio based plastic alternatives. A new type of polyethylene was derived in a study in Germany. There the renewable oil is being reported, and they have a greater recyclability as well as the recovering most of the original polymers by using this type of materials in that as suggested in the study. More recently, there is an interest on sustainable plastic, which has resulted into rapid increase in petroleum-based biodegradable plastic. Toxic chemicals used in plastic products production especially hamper the effectiveness of many of these so-called sustainable solutions, because if we are just recovering the plastic or microplastic, but how about those toxic elements or chemicals which are mixed with those product or those compound? So that is more problematic. So extended producer responsibility program, prevention initiative to reduce single-use plastic and plastic treaty of the entire plastic life cycle, increased consumer awareness and improved performance measures are required in order to have a sustainable solution for the plastic pollution. Now, as I said, in second part of this talk, I also talk about their mechanisms, how they are interacting with the water as well as the surrounding environment. So first question here comes like, why do this micro or nano size particles behave differently? And there is a very simple answer here is their surface area, because smaller the sizes, bigger their surface area, So that means they are more exposed to the environment or surroundings, so they can be more reactive. They can take part in any interaction more easily. For example, this if you see this cartoon here, I have a surface area of sand particle to silt as well as the nanoplastic here. Almost the same one sand particle can produce 24 multiplied by 10 to power 5 times more surface area if they become of nano sizes, just from 2 millimeter to the nano sizes. So how they are basically being transported? I just through this cartoon, if I want to demonstrate you, like if you have a plastic products which are dumped into the landfill site, and what if they are generating the microplastic? So they can first, if they have enough water, like a rainy event, like monsoon season, if you have these days, that means they may infiltrate. Or if you have a landfill site with the liners, they may also have some leakage. And if they found that, that means they will move to the subsurface system, and ultimately they can go and mix with the saturated zone and flow with the direction of groundwater flow. And if there is any drinking water supply well or irrigation well, that means they can be injected, they can be sucked by this with the water and can harm the pollute the water sources. So the mechanism for the persistent of the plastic, if we see the water bodies as well as the surface, there are a lot of things basically are happening once they are in micro sizes. Because if we remember correctly, this microplastic or plastic product have both density which is lighter than water as well as heavier than water. So they can either float to the surface or they can also get deposited to their bed. So both are happening, but due to their disturbance in the flow, like a buoyancy or transient condition, they may also interact from the surface to the bed or from surface bed to the surface, or they can just stay in the medium middle of the water body. So a lot of things are happening by movement. Not only in that, even in the surface also they may either flow with the air, or they can roll or get deposited by at the land surface as well. So if we list here the fate of microplastic before reaching to the ocean, a lot of things are responsible, like hydrologic characteristic, watershed pattern, physical properties of microplastic itself, like what type of microplastic are, as well as the hydrodynamic behavior of the microplastic. That means how they interact in the suspension or in the air. So the hydrodynamics of microplastic basically governed by the buoyancy, gravity as well as drag force, because both are important here, like buoyancy and gravity, because as I said, the density is very variable. They vary from less than 1 to the higher than 1, that means less and more than the water density. If we see the subsurface system, there even it is more challenging, like if they are present in the groundwater or saturated zone, then they not only can stay in the water, but they also can stick with the sand surface if they are in the saturated zone. And if they find some other contaminants nearby, there are also chances that they may stick with the microplastic. And if we are dealing with the unsaturated zone, this is even more challenging, because you have air also present in this, in between the water and sand. So there are chances that they can either be in the air-water interface, or they can just be within their layer of the water, that means in the solid water interface or in the water. So a lot of process which can determine their interaction if they are inside the subsurface zone, whether it is in saturated or unsaturated zone. But of course, this is not that difficult, because lot of mechanisms are has been understood for other type of micro and nano size particles, and this is just to replicate, just to model and to experiment for the microplastic, and studies are coming up for this as well related to microplastic. So after this, in the end of this webinar, I will show you one of the case study which was about the microplastic in marine environment. And here this is very important, because very high concentration of microplastic are found in several coastal areas. For example, almost like 300 microplastic particles per kg of sediments was found in the North Atlantic island of Spain. More than 40 million particles per kg of sediments was found in Rhode Island. Almost like 100 particles per kg of sand of salt was found in one of the study in MoEF&CC channel of Bangladesh. Then significant quantity of microplastic are found in Bay of Bengal, for example, via Ganga Brahmaputra Meghna River basin, in both in India and Bangladesh. So a lot of studies are coming up in this region as well, and multiple sources of anthropogenic activity which are basically leading to Bay of Bengal and also to the different islands. So this study was also done in the MoEF&CC channel situated in the Bangladesh region or Bay of Bengal. So here actually it was divided into 6 different zones based on their intensity, like some are situated in the human settlement area, commercial settlements or salt production field, as well as the agriculture, near the agriculture land or mangrove plantation. So I don't go in detail into this, but this is the overall. Here are the method of sampling. So for both, like in general, researchers are using like this kind of quadrant method for collecting the sediment sample for analyzing the microplastic, or they are using this mantra trawl for collecting the water sample for understanding the microplastic. And then in the lab, we bring the sample to the lab, and then most likely people are following the density separation for separating the microplastic from sediment sample as well as the water sample. So here some of the results are for the abundance of the microplastic. On average, about 7 to 138 particles per meter cube of the sediments was found, and about 0.1 particle per meter cube of water sample was found in all the samples. Of course, in some location they are in higher concentration, like the maximum at the mouth of the tributaries of the rivers, that means nearby the wastewater discharge side, and the lowest in the near the high wind or quick settlement area. That means they had not enough time for polluting this sediment or the water sample. In terms of their size distribution, because this is very important to understand their sizes, so that was also done by using these 3 size categories, and it was found that most of the microplastic were ranged from 1 to 5 millimeter, like they were more dominant, but it was found in almost all the sites with low and low or high concentration. In some other sites which are sometimes they follow probably different sampling method or have different sources. They had, for example, in Polish Baltic beaches, they are having relatively smaller sizes in dominance. And here in another study in South Andaman in Indian side, they have different range of microplastics. So it varies depending on, there are a lot of factors which are basically responsible for this. If we analyze their different types of the microplastic, like which microplastic types are present there, like films or fibers, pellets, foams, fragments. So these are 5 common types which are mostly studies in almost all the studies they try to understand, because they are very common, or some are like irregular shape, which has no definition so far. And so in these studies, we found that film or seeds were the dominant in both sediment and water sample. This might be happening because of anthropogenic action, like sources, or as well as in the region. In other region, in China or India as well, they have found film are also dominating. But again, these are not always fixed, like which type of microplastic may be dominant. So they are much more dependent on the sources. People also studies their color, because they help us to identify their types as well. And in this studies, the white microplastic were dominant, and like white or transparent color of this. In both actually sediment and water sample, we find more. Of course, there are other like black plastic, microplastic were also found there. If we see their polymeric types, because I said this determine their toxicity level, as well as they also determine like the type of plastic, determine like how their surfaces, that means how they may be interacting with their other chemicals, other toxic material present in the surrounding. So it was also done here, and one can use this FTIR nowadays. This NIR based, like microscopic FTIR, very much useful, which is more automatic, so they can give us with better accuracy of their quantity. And here we found like all five types of the microplastic were present there, but among them this polypropylene were dominant, like the first one here we see, which is dominating in both soil and water sediments. So if I conclude this case study, then this study site, which is the Mohescali channel of the Bay of Bengal, provides some new insights in terms of their abundance and spatial distribution, geological location of the channel, pollution load, and from various tributaries, as well as the wind direction, surface current, tidal influence, or sedimentary budget were all the factor in terms of their concentration. And the most common microplastic, as I said here, were the films and this white and transparent color were dominating in this study. So ultimately, the microplastic trophic transfer as well as the bioaccumulation can cause considerable ecological damage to this study site, which was concluded. At the end of this webinar, I'll just help you with give my opinion on some of the future research. Like, one can focus on the fate of microplastic in groundwater and their remediation process, because not many studies even now are present here across the globe, including India, and the remediation is very limited. Even we still talk about their concentration, we talk about their mapping, but there is very less thought about how they can be remediated. So one should start thinking about that and working on that direction as well. Local to global scale mapping of microplastic is very much required, by the policymaker and the society must act on their reduction in the local to global scale. So once we have a very good understanding of their mapping, their presence in different ecosystem, then one must act on how to reduce it, and in terms of their quantity or by the use. This is a very important point here. So we find now thousands of studies come up with different results, different conclusion. So a standardization of microplastic pollution is very much required in order to find a common remediation approach across the globe. And in adverse environmental impact of micro and nanoplastic and their standard treatment strategies should be urgently to be practiced in different stakeholders across the globe. So this is the 4 points which I thought I can highlight before ending this talk. For example, this was one of a review paper by us, our group, trying to understand how the microplastic is interacting with the plant as well as their heavy metals and as well as affecting the health. Then this studies, again it is a review paper by using a biochar for remediation, like how the biochar is going to interact with microplastic. I use biochar in my study a lot, so I thought of doing this, and there are a lot of scope here in using biochar as a tool for interacting. Of course, one can modify the biochar or have a activated biochar for the interaction. So here also there are more scope. I use some of these references in today's talk. Thank you very much for your attention. I will be very much happy if you have any feedback, comments, or question.
Thank you, sir, for the lecture. Now this is the question answer session. So if anybody has any question, they can raise their hands. Miss Akansha Yadav wants to, okay. Miss Akansha Yadav, you can ask your question.
Yes, please.
Akansha?
Ask her to unmute and do that thing. Akansha. Miss Akansha, are you there?
Sir?
Yeah, please. You raise your hand. Please ask. Do you have any questions to be asked?
Hello.
Yes, you are audible. Do you have any comment or any question?
Sir, first of all, good morning, sir. And sir, I have a question regarding microplastic in soil. Actually, I am pursuing my PhD in this topic. You already talk about groundwater and freshwater ecosystem. But please verify something about soil.
What a specific thing you want to know? Because I think soil also nowadays there are studies which you can find in the literature as well as some review paper which talks about their interaction with the soil.
Sir, I already they say their effect is physiochemical properties, but they cannot resolve how they can affect. That's why I'm a little bit confused about these topics.
No, I think you have a very good topic actually. This lot of things can be done. Of course, not only their analysis. There is a challenge actually. Once the microplastic in soil, I know there is a very challenging here to can use the density separation for their quantification. But once you do that, then as a very standard method here, we try to analyze their types, sizes. So once you know the polymeric type, then you can understand their toxicity level as well. And if you have any specific interest in any particular toxic, any pollutants, then you can identify them as well, how they're interacting. So that is about like just their mitigation part. I don't know if you want to also move with their remediation approach. That will be, of course,
this is my initiative phase in this topic, and actually I am currently doing FTIR that I found that propylene and polyethylene are much more found in agricultural lands which are using plastic mulching. Their source, basically, main source are plastic mulching.
That's
sir,
correct.
I can't identify how the soil interacts with microplastic, how they leach out in groundwater, their mechanism already bothered me a lot.
Okay, that's very good actually. I think that that is why I said I have generally worked in their mechanism of different type of nanomaterial or colloid like microplastic, micro size particle. So basically for microplastic also one can use the similar approach. Like if you find how they are leaching, already tools are developed. So you don't have everything to develop by your own. So you can borrow those technology or understanding which are available in the literature about their leaching, their transport, and see how whether they are working for yours or not. So like if you have to understand their transport, so you can also develop, start any lab type model like flow through column and see how which microplastic are transporting faster or slower or how much, what proportion. So that kind of thing can be replicated in your study as well. And I understand you cannot directly start with the natural soil. So you may start with the sand and then move to the natural soil as well, wherever your site is.
Thank you, sir. Thank you for the answering. I think more, Akansha, you can get in touch with them, you will get more details. So I think next is Shruta Kriti Nagandi. Please raise her hand. So,
yes, sir. Yes, sir.
Yeah, please.
First of all, good afternoon to all the eminent personalities who added leathers to their cap. I am pursuing my studies like BA program, first year in Delhi University. And I have represented like recently in Life for Environment challenge, like the conclave, youth conclave, conducted, from JNU itself. I am one of the participants in it. So addressing the concept of microplastic has actually, we had an insightful session with all the students from 28 states of India. So knowing from that, sir, the point you have mentioned here, it actually intrigued me a lot. Like we are finding, we are actually having a lot of concepts already we have discussed so far. We have had debates and discussions on plastic, but the remediation is still left out. What I have seen is there are many alternatives of plastic, but it is that we are missing the common thread. The common thread that is linking the indigenous people and the people living in the metropolitan areas.
Yes.
So what do you think about, what do you comment on that, sir?
Yeah, I think Shruta, you have very well summarized the point, and I think both points are very important. I also mentioned that remediation, there are still very less studies are there, very less work, but it doesn't mean that it has not been studied. So, for example, one can use like bioremediation or phytoremediation. So these are very like more sustainable approach and also can hopefully work for the plastic compound as well. Or you can segregate it and recycle it if it is slightly bigger sizes. So these are some of the initial thought on the treatment or remediation work. And what was your second one? You said indigenous people, like, or metropolitan area, right?
Yes, sir. Sir, actually, for stating this, I have a very valid point. For example, in Assam, if we can see, there are water hyacinths. These are the plants which are being used, like these threads of the plants are being used and they are made into baskets. And in Varanasi, we are using the flower petals to make agarbattis. So these are replacing plastic, but this is not actually finding its roots to the common people. Like from common people to the higher class, it is an alternative, but this is not reaching out. So what should be the reach out approach?
I think there should be, in my opinion, just one approach may not work and may not solve the overall. This is a very big issue, actually, microplastic pollution. So, as you correctly said, that can be one of the approach. Like we should reduce their use, and that will certainly help. And then not only that, there should be society should also come up, like not to recycle them more and more, and then not to dispose, because why this microplastic and nanoplastic problems are man-made mostly, because one can avoid it if you recycle the plastic product. Like I'm talking about the for example secondary microplastic which are being generated, that can be reduced and or even stopped, because if we don't allow the plastic product to chemically, biologically or physically degrade and convert into micro or nanoplastic, then we can solve a lot of the problem. Of course, the primary microplastic can also be reduced to some extent by using some kind of filter and other things which are being suggested. For example, in washing machine, if we have a very good filter that may reduce it before getting into the wastewater, you can filter out those microplastic from there as well, like those fibers. Similarly, the secondary microplastics certainly can be reduced if we use them properly. And the third one is like approach should be from the policy maker, like our government. One should have, or for any pollution, one should have the facility. Like what we do normally here, if we don't find any dumping box, we have no way, even though you are aware, you are trying to reduce the pollution, we have to throw them outside. Yes. But if we have a facility, we can at least think of, or some of us probably can use the dustbin. So just one approach may not work, but collective effort from different sectors, different stakeholders may reduce it or may reduce and pollution. Thank you.
Thank you, sir. Thank you, sir. I think EIACP Nagaland, they raise their hand. Nagaland, please.
Good afternoon to everyone. This is from Nagaland, EICP, Nagaland Pollution Control Board. Taking this opportunity, I would like to impress upon the JNU. Now, the solid waste management, it is an issue for every one of us. And we all know that all the solid waste, except the plastic, are biodegradable, except the plastic and plastic-based products. So I would like to request JNU, being a premier institute, to impress upon the policymakers not to lose focus on this plastic waste management. Because, as I said before, all the other waste are, in a way, compostable, except the plastic. So, coming to solid waste management, if we can resolve this issue of plastic waste, I think the rest is taken care of. And the next thing is, I would like to ask Sir Prabhakar. We know that burning, not necessarily the plastic, burning of any open burning is banned. But then we come across, there are incidences where we see plastic being burned. So when we burn plastic, does it pollute air by way of of smoke, or it releases these nano microplastics into air, causing air pollution, or it causes pollution by the smoke itself, or there are nanoparticles of plastics released to the atmosphere. Thank you.
Thank you very much for both actually question, and your suggestions are very valid. One should reduce the use of plastic from the solid waste, and I hope our policy maker will hear this and have something. Your second question about the open burning of the plastic products. I don't know, I cannot say for sure, but more likely the pollution is in the air, that means through the smoke. So they generate a lot of harmful gases and have atmospheric pollution. But we cannot ignore, we cannot 100% say that the and nanoplastic will not go to the air in this process, because not only like they may not go directly, but many times if you burn something, always see some unburned or half burnt material like ash, which are probably fly together with the air in this process. But otherwise, in my opinion, the harmful gas is more concern here if we are burning in open. So that is my answer, but I'm not 100% sure like what proportion will aid this nanoplastic also together or while burning, but more likely air is more dangerous in that case. Thank you.
Is there any more questions from the audience? Madam Kasuri, or maybe any faculty members, students? Sir, I have a few questions.
Sure, sir, sure. Please.
Sir, you are talking about the microplastic and the nanoplastic and all. But what is the lifespan when it's produced? How long it will take? It varies from particle size to depend on the lifespan, depending on the size, or it is or how it is persist in the environment, or what?
I think this is very valid point, sir. As I say that this plastic or microplastic are also regenerated by they are more in terms of their sizes, which you mentioned. So for example, if today is the bigger plastic, if they stay in a similar environment, like either exposed to sunlight or in the submerged in water or in the air, they may further break down by chemical, physical degradation, or even biological process. They may convert into nano sizes or slightly smaller sizes. So like throughout the process they will generate it. So we cannot 100% sure say that today we have this much quantity of this particular sizes. After 10 years it will stay there. So that is one part. And the second problem here or second issue may happen is also they are very much transport. They may not stay at one place. So today they are in water, tomorrow they may be in the soil, or they can even further penetrate to the soil if they are in the water bodies, or they even in that location also they can further get transported. So in terms of their spatial and temporal distribution, both are responsible for this, in my opinion. Thank you, sir.
Yes, thank you, sir, for the informative and engaging lecture where you talked about the microplastics and how it interacts with our environment, our ecosystem, and causes ecological disturbances. It was very enlightening, sir, and I'm sure the students will definitely benefit from this lecture. Thank you for giving your valuable time to us. And I would like to thank now our coordinator, Professor Paulraj sir, and co-coordinator, Professor Kasturi ma'am, for guiding us and giving us suggestions and making this webinar happen. I would also like to thank Ministry of Environment, Forest and Climate Change for providing financial assistance. I thank all the faculties of SES, students, EIACP centers and all the attendees of this seminar. And last but not the least, I would thank the team of EIACP JNU, Ms. Sandhya, Ms. Ruchika, Mr. Ajmal for their work and making this webinar successful. Thank you everyone.
Thank you. Thank you so much, sir. And hope when you come this side, please let us know. We can have the offline meeting because students are on leave today. Actually, JNU is on holiday.
Okay, no problem, sir. I will be more than happy to interact anytime, so I will be in touch with you. And
so when you pass through Delhi,
sure,
sometime let us know. We can have it offline meeting so that more students can be interacted. I can invite the neighboring institutes, students also. We can have a proper kind of discussion. So this is a short notice plus the holiday. But much.
It will be my pleasure, sir. So thank you very much for this.
Thank you so much, sir. Thank you.
Happy to get interactive. Thanks a lot, sir.